In this video, and actually in this series of videos, we are going to look at the unit circle, getting it created and understanding how it works and what it does to relate to our trigonometry. So this first part is part one, labeling angles. You may want to have a couple of things. First of all, you may want some highlighters. I am using 3. That's what you're going to need to do some color coordinating. I'm also going to use some colored pens. You don't necessarily need colored pens. But I wanted to make sure that we are all seeing the differences and all of that. I think that'll help. And then you also want the papers that were printed from the file that I gave you. So the unit circle, this first page. The second page isn't necessary for you to have, but if you want to, I'll be using these triangles throughout. I'm going to set that to the side because I've actually already cut some out. And we're just going to start here with our unit circle. So let's talk about our unit circle first of all. We're going to be talking about these angles here. And when I'm talking about an angle, what I'm talking about is an angle in standard form. So initial side on the x-axis, vertex at the origin, and then the terminal side here. So this angle here would be 60 degrees. Now, I've labeled certain ones. And we're going to define those two words before I go around and actually label them. But I want you to see what I've done. So I'm going to use my protractor. You don't need to use your protractor because you'll be able to see on mine. But if for some reason you didn't get it printed and you need to create your own, you can use a protractor to create it. Okay, so here we go. So obviously this is 0. If I go from here to here, that's 30. 45, 60, 90, 120, 135, 150, and 180. So those are the angles from the first two quadrants. I could flip it around and add an 180 to everything and get the others, but I don't need to do that. Here's what I want to point out. In the second quadrant, in the first quadrant too, reference angle is 30, reference angle is 45, reference angle is 60. Here, reference angle is 30, reference angle is 45, reference angle is 60. See that? For the 150, the reference angle is 30. For the 135, the reference angle is 145. For the 120, the reference angle is 60. So those reference angles are going to be important. Same thing is going to happen here. So I'd have to add 180 because I don't have one of those full circle ones, but reference angle is 30, reference angle is 30, reference angle is 45, reference angle is 45, 60, 60, okay? All right, so we're going to go, first we're going to go around and we're going to label all of the angles in degrees. So, see that? Those are little degree symbols all the way around. And we're going to start at 0. So that's initial side and terminal side, both on the x-axis. Okay? And actually, I just realized I need to back up a step. I need to define the unit circle. It's a circle with a radius of 1 unit, hence the word unit circle, centered at the origin. So this distance here is 1. That distance there is 1, because it's a radius. All right, and then here we already said that's 30, 45, 60, 90, and then I'm going to come actually here. My reference angle was 30, so subtracting 30. Reference angle was 45, so subtracting 45. Reference angle was 60, so subtracting 60. And then I'm going to add this way. So reference angle is 30, so I'm going to add 30. Reference angle is 45, so I'm going to add 45. Or you can just add 15 to that. Reference angle is 60, so I'm going to add 60. This one is 1 right angle, 2 right angles, 3 right angles. So 3 times 90. And then I'm going to come here and subtract, because I always like to think of it from my reference angle. I could also add 30, add 45, add 60. but I like to always think from my reference angle. Reference angle is always from your x-axis. So I'm going to subtract 30, subtract 45, subtract 60. And those are all the angles going around in degrees. Now the only other thing we're going to do in this video is we're going to go around and we are going to label the radians. We are going to label the radians. So we're going to label the same angles, but this time instead of using degrees, we're going to use radians. So I told you I was going to find some things and I didn't. Let me define some things for you real quick. So what we just labeled were our quadrantal angles. Those have a terminal side on an axis. So 0, 90, 180, 270, 360, and I could keep going. Multiples of 90. So those were here, 0, 90, 180, 270, 360. I can also write those as radians. So 0 degrees is also 0 pi, 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, 360 is 2 pi. Those you just kind of need to memorize, but remember 180 and pi are the same. 90 is half of that. 270 is 3 of the halves, 3 of the pi over 2. And then 260 is a full revolution, or 2 straight angles, which would be 2 pi. Now, our special angles are the ones that have reference angles of 30, 45, and 50. Why do we care about those? Because of our special right triangles. That's why we care. I have these memorized so I don't have to convert every single time, but they're super easy. If you do 180 divided by 6, you get 30. If you do 180 divided by 4, you get 45. If you do 180 divided by 3, you get 60. Okay? So this is what I'm going to use as I'm going through. All right, we're going to talk about another way to know those as well. So let's start with our quadrantal angles here. Let's start with the ones that are on the axes, because the radians are a little bit more complicated, only because they're pretty new to us. So 0, this is pi, this is half of pi, and then this is 1, 2, 3, 3 of the half pies. And then, of course, as I come around a full circle, that's 2 pi. Okay? Now, I just said 30 degrees was pi over 6. I remember 30 and 60 because they're kind of flipped. 30 is pi divided by 6, 60 is pi divided by 3. I want to show you where that's coming from. Okay? So ready? I've got my triangles here. The only thing I'm going to do right now is show you. If I take 30 degrees and I line it up going all the way around my circle here. I cut mine out on color paper. You'll see why later. Right now I'm just going around my circle. And I'm just using 2 different colors to make it a bit more obvious. Look at that. 1, 2, 3, 4, 5, 6. Cut it into sixths. So that's pi over 6. Now if I use the 60-degree side, that's only going to cut it into 3s. See? 1, 2, 3. Okay? Now if I use the 45, I don't have 2 different colors for these because I didn't need it. See, 2 45s make 90. And 4 45s make 180. Ta-da! All right, so 45 is pi over 4 because I'm splitting into 4. Okay, now for my second quadrant, I am going to go and subtract. So this is going to be pi minus 30, or 180 minus 30, so pi minus pi over 6. Pi minus pi over 4. Pi minus pi over 3. For third quadrant, I'm going to add. pi plus pi over 6, pi plus pi over 4, pi plus pi over 3. And then for my fourth quadrant, I'm going to subtract 2 pi minus pi over 6, 2 pi minus pi over 4, 2 pi minus pi over 3. Okay, now don't let that get too bogged down. Look, all you're going to need to do is common denominators. Pi minus pi over 6 is 5 pi over 6. See that? 6 pi. Pi plus pi over 6 is 7 pi over 6. And then 2 pi minus pi over 6 is 11 pi over 6. So you're just doing common denominators. Same with the pi over 4. I made a boo-boo there. That's a 5. And then same with the pi over 3. You don't need to write those down, but I just wanted you to see them because I'm going to do them in my head. So pi minus pi over 6 is 5 pi over 6. Pi minus pi over 4 is 3 pi over 4. And then pi minus pi over 3 is 2 pi over 3. And then going forward, pi plus pi over 6 is 7 pi over 6. I'm just adding 1 to the numerator. Pi plus pi over 4 is 5 pi over 4. And pi plus pi over 3 is 4 pi over 3. And then again, I could keep adding, but I like to go with my reference angle. So 2 pi minus pi over 6 is 11 pi over 6. 2 pi minus pi over 4 is 7 pi over 4. And then 2 pi minus pi over 3 is 5 pi over 3. And then that gives us all of our radians as we go around here for those degree angles. Now that is all we're going to do in this video, but before I close it out, I'm going to go through and do the radians a second time, kind of using a different method. And it's what I actually do so that I don't have to do all this adding and subtracting in my brain and then make mistakes. There's different ways to like memorize. You know, they'll go through, if you watch videos, they'll talk about how that's 4, 5, 7, and that's 2, 3, 5, and that's 5, 7, 11, and they're all 3, 4, 6, 3, 4, 6, 3, 4, 6, 3, 3, 4, 6. I don't like memorizing. So here's what I actually do. We talked about how the pi over 4 splits this into 4 equal pieces, which means it splits 2 pi into 8 equal pieces, right? So what I actually do is I go 0, 1 pi over 4. I'm just going to do the pi over 4s. In fact, let's go ahead and do a little bit of color coding. I'm going to take all my angles, ignoring the quadrantal ones. I'm going to do all my angles that have that pi over 4 or that 45 degrees as a reference angle. I'm going to make those purple. And even though we're not going to use this yet, I'm going to go ahead and highlight this purple because we're going to use it later. Okay, so 0, 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4, which reduces to pi, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, 8 pi over 4, which reduces to 2 pi. Now, for your pi over 6 and your pi over 3, you know how, or let's do 30 degrees, 60 degrees. 60 is a multiple of 30. So I can actually kind of do these two at the same time. I'm going to color code first. So I am going to take my 60 degree angles and I'm going to make them pink. In other words, these have the same reference angle. So the 60 degree ones I'm making pink. And then the 30 degree ones I am making orange. I'm actually going to do these at the same time. Alright, ready? So let's do the 30 degree ones. It split this into 6. Ready? 0. 1 pi over 6. Whoops. Didn't get that highlighted. There we go. So So I'm using orange and pink right now. 1 pi over 6. Watch this. 2 pi over 6, which reduces to pi over 3. 3 pi over 6, pi over 2. 4 pi over 6, reduces. 5 pi over 6. 6 pi over 6, reduces. 7 pi over 6. 8 pi over 6, reduces. 9 pi over 6, reduces. 10 pi over 6, reduces. 11 pi over 6. 12 pi over 6, reduces. So that's the little trick I actually use when I'm labeling those. Alright, so that's it for this video, because I don't want the video to be 45 hours long. Make sure that you have this all filled in, and then in the next one, what we're going to do is we're going to come in and we're going to fill in all of those points. That's going to be our next task.